It has been several decades since humans took their first step on the moon. The world was glued to television and radio, waiting for the news that would go into history.
It's one small step for man, one giant leap for mankind.
That's one small step for man, one giant leap for man.
This was just the beginning of missions to the moon. Now there is a new emphasis on returning to the lunar surface.
Humans will move to other bodies in our universe, I'm quite sure. And the next body to be reached is, of course, Moon. The Moon is quite close. You can travel there and back within 1 week, as we know.
Today, the European Astronaut Centre prepares and trains astronauts for missions to space and to the International Space Station. To go further out in space on exploration missions, EAC, together with ESA and other international partners, tries to identify and enable technologies that will support missions to the moon within the next 20 years.
We have a lot of simulation capabilities here at EAC. We have a network that is connecting to the other centers around the world at ESOC, but also with our partners in NASA and in JAXA. So there is a lot of capabilities that we have here at EAC that could be used.
Long-term human spaceflights to the moon include challenges that need to be investigated and solved with new operations and technologies.
The moon, of course, is a lot further away than the ISS is. Communication delay might be a little bit more of an issue. Crews are going to have to be more autonomous. The environment is a lot different. We're not going to be weightless on the moon, but we are only going to have about a sixth of the Earth's gravity. We're going to be exposed to radiation, to dangerous radiation. We'll need ways to protect ourselves.
In addition, the lunar day and night cycle is 14 Earth days long, and temperatures can change from -180 up to +90 degrees Celsius. However, the goal is not only to return to the moon, but to aim for permanent elements on the lunar surface.
Moon can be a very important stepping stone to the further robotic and human exploration of our solar systems. The main intention is not only to go to the surface, but to stay there for longer times.
The preparation of such missions will take several years of investigation. That's why the EAC decided to involve a new generation of scientists and engineers by starting up a new initiative called SpaceShip EAC.
It's an initiative that was started by Frank Devin, the head of the centre here at EAC, in 2012. And it looks at using the facilities and the expertise we have here at EAC to help further the cause of human spaceflight, specifically how we can develop technologies that will enable human spaceflight in the future. I think it's interesting for students to come and work with us because we have a number of really interesting topics that are related to human spaceflight. The students will join very much a multidisciplinary group, a multinational group, and they get the benefit of working in a very, very professional environment. And so they get to do a bit of research on a topic and feed in some of the expertise that is available here on site to help further their project.
The team is also very special since we're from all over Europe, France, Italy, Switzerland, Ireland, UK, and loads more countries. So it really brings a lot of good ideas to the table, as well as the fact that we're international, we're also multidisciplinary. So this also generates new ideas, and it's very easy to collaborate with all the team members.
SpaceShip EAC helps in finding solutions for the challenges we will have to face on the moon. The team looks at topics relevant to lunar exploration and operations, such as energy provision, telerobotics, 3D printing in space, food supply, and mitigating the effects of moon dust. One of those solutions that the team is investigating is 3D printing of a lunar habitat. For this purpose, an abundant local resource on the moon, the so-called regolith, can serve as a building material. A rover would process this regolith together into harder substances, that could protect the astronauts from solar radiation, micrometeoroids, and high temperature fluctuations. The process could also lead to the release of water that is contained in the regolith. This could be converted into drinkable water and provide the astronauts with crucial elements such as oxygen and hydrogen. Astronauts will be supervising the robotic activities so that humans and robots work together in unison. Another example that the SpaceShip EAC team looks at, in collaboration with European researchers, is food sustainability. In order to have longer missions, astronauts need to become more self-sufficient. Providing conditions to grow useful crops and plants for food is a relevant challenge. But can plants even grow in such an extreme environment as found on the Moon? To find that out, the team is building a plant growth system, simulating the same growing circumstances that would be found on the Moon. If we know exactly how to grow food there and on other planets, we will be able to stay there for longer periods. SpaceShip EAC relies on motivated students with creative and fresh ideas. Together with the space experts at EAC and international partners, they can contribute to future missions that enable our exploration of low Earth orbit and beyond. If we manage to establish a permanent presence on the Moon, we might be able to construct a whole moon village, and from there go even further, to Mars. For the first time in human exploration, we will find a way to settle on another world and pave our way to further expansion into our solar system.